All right, so in this video, we're going to look at this direction of the theorem. So we assume that we have a way to label the vertices of our graph so that the resulting adjacency matrix is block diagonal, and that this is in fact that block diagonal adjacency matrix. Now let's see why the graph must be disconnected. So before I draw the graph, which you will see is in fact disconnected, let's think about why it must be. So this block, what I've called A1, this is an adjacency matrix. It defines some graph. It defines some graph, let's say G1. And this block, what I've called A2, is an adjacency matrix in its own right, and it defines some other graph, let's say G2. Now because block diagonal, to say something's block diagonal, we have a block of all zeros here, and we have a block of all zeros here. Take any vertex, let's take any vertex of G2. Right, now notice these are V1, there's 5 vertices, right, because this is a 5, because this matrix A is a 5 by 5 matrix, so we have 5 vertices. And so let's say V4 over here in G2. Because there's all zeros in 0, 2 here, because there's all zeros here, right, there's no edges over to G1, right? And similarly, because there's all zeros there, no ones there, there's no edges across to G2. And so the graph must be disconnected. A block diagonal adjacency matrix means that the graph must be disconnected. And now we can actually draw this thing. For this example, let's say this was A1. Let's see, we got V1, V2, V3. See, 1 goes to 2 and 3, 2 goes to 1 and 3 goes to 1 and 2. So that's that thing. And that's that one. And you can see that, in fact, with this example, the theorem is true.